So first I need to talk to you about some properties of integrals, and then I'm going to talk to you about the fundamental theorem of calculus. So number one, this problem is an odd function. It's odd because if you look at it, if you turn it upside down, you get the same function. So we have an odd function, and what we know is that the area, or the integral between 0 and a, this part right here, is 5. Alright, so the first question asks me to find the integral from negative a to 0. So it wants me to know what this part is. Well, because it's odd, those two areas are the same, but because it's an integral, that makes this be a negative 5. Alright, next it asks me to figure out what the integral from negative a to a would be. Well, if I know that that is 5, and I know that that is negative 5, I just add that together and I get 0. Okay, number 2. So we still have an odd function. Again, if you look at it, if you turn it upside down, it's still the same. And what we know is that from negative a to b, so from negative a to b, that we get negative 10 for the integral. So the first question is asking me to figure out what negative a to a would be. Again, because it's odd, the top area is going to cancel out with the bottom area, and I know that this would be 0. So the next question asks me to figure out, well, what's going on from a to b? Well, negative a to b is negative 10, and I know that if I want to find from a to b, well, I've got to add all of these together would add up to the negative 10. So if I just want this part right here, and I know that all of this is 0, and that plus that has to equal negative 10, well, that means this has to be negative 10. Alright, next problem. This one is an even function. An even function flips it across the y-axis and gets the same thing on both sides. And they tell me that from negative a to a, that the integral is negative 10. So the question is for me to figure out, well, what's going on from negative a to 0? Well, because it's even, part of the negative 10 is on one side and part is on the other side, so that should be negative 5. Again, on number 4, this is an even function because it's symmetric on both sides. I know that from a to b that I have 5. So here's sort of a rule. Notice that only thing that happened here to here is that I switched the two letters. If I happen to put the bigger number on bottom, whatever the answer is from the smaller to the bigger, it's the opposite. So from b to a is going to be negative 5. Alright, next it asks me to find negative b to negative a. Well, because it's even, the same thing's going to happen on both sides, so I know this is also going to be 5. And then the last one, negative a to b, all that's happened is these numbers are switched back. Well, since negative b to negative a is positive 5, negative a to negative b is negative 5. So I just wanted to sort of give you some ideas about even and odd and how that works. Now we're going to talk about the fundamental theorem of calculus. Oh, there's one more problem. I'm sorry. There's a couple more problems. We'll get to fundamental theorem of calculus. So this one doesn't have a picture, and it doesn't tell you anything about even or odd. But what I know is that the integral from 4 to 6 of 3 times f of x is 10. And I know that the integral from 6 to 5 of f of x is 2. So the first question is for me to figure out what the integral from 4 to 6 of f of x is. Well, the thing that is true about integrals is if you multiply a number, you can take the number out of the integral. And then you can divide it, so I know that this is going to be 10/3. The next one, it says the integral from 6 to 5 is 2. So what's the integral from 5 to 6? Well, that should be negative 2 because the only thing that's happened is those two things are switched. And then lastly, the integral from 4 to 5. So looking at these two answers, I know that depending on what the graph looks like, it really doesn't matter. But here's 4, 5, and 6 maybe. Pretty sure it's all above, well, some of it's above and some of it's below. It really doesn't matter. So I know that all of this is 10/3. And I know that this is negative 2. So if I want to find this, basically I'm just going to subtract. I'm going to say, well, the integral from 4 to 5 is the integral from 4 to 6 minus the integral from 5 to 6. So I'm going to have 10/3 minus negative 2. So that would be 16/3. Because you take the whole integral, you subtract off the little part. And I know that the picture's not right because I know that from 5 to 6 it's negative, but it doesn't matter. To figure out what you want, that's how you figure it. Okay, here's another one, number 6. I know that the integral from 2 to 3 of f of x is 4, and 2 to 3 of g of x is 5. So the first question says to figure out the integral from 2 to 3 of f of x plus g of x. It works exactly like you think it does. You add it and you get 9. The second one says to square the integral of 2 to 3 of f of x. So this would be the same as 4 squared, which is 16. I do want you to know that that is not the same as that. Those two things are different. This is one that we cannot figure out by the problem given. But that is not the same as putting the square on the outside of the integral. The next one, it's okay to multiply by a number, so it works like we think it does. 4 times 4 is 16. The next one works exactly like I think it does. It would be 2 times 4 minus 3 times 5. So that would be 8 minus 15, which is negative 7. And then lastly, this one's just different because it has z's. But if it's true about x's, it's also true about z's. So this is still 4. Now the fundamental theorem of calculus. So the other day we were talking about the fundamental theorem of calculus, and we talked about it in words. And we said that, okay, if we have something like this, the integral of 2 to 3 of the velocity. Well, if I interpret that, that interprets into change in position, which means I find the position at 3 and I subtract the position at 2. Well, that's the fundamental theorem of calculus. And what it says is that if I have the derivative, velocity is the derivative, that if I want to find this integral, then I need to find the original, which is position, plug in the two numbers and subtract. So this down here is the actual rule. Little f of t is the derivative of big F of t. I don't like the way that they write it. I would rather them write this. But the notation you'll normally see is the one written in red. Basically, it's saying the integral of the derivative from a to b is the same as the original evaluated at b minus the original evaluated at a. So let's look at some problems. So this is the original, and this is the derivative. Do you agree? The derivative of 7t squared is 14t. All right, so if I want to find the integral from negative 5 to 7 of 14t, then the first thing I need to do is to figure out what the original equation of 14t is. Well, it's already given to us. It's 7t squared. So we find the original, and then we evaluate it at those two numbers, and then we subtract. So 7 times 7 squared minus 7 times negative 5 squared. And then I work that out. And you get 168. Now, you don't have to find this right here. In the next unit, we're going to talk about how you go from the original to the derivative. For now, you're going to kind of be given to it or led to it, so you're not going to have to try to figure out, okay, well, what's the original equation? It's going to sort of give it to you. So in number 8, they're telling you the original is cosine. So they're saying, okay, what's the derivative? Well, the derivative of cosine is negative sine. Okay, let's look at the problem we have. We have from pi to 2 pi of negative sine of t. Well, that's the derivative. I already know that from here. So to find the answer, I go to the original, which is cosine, plug in the pi, and then cosine, and plug in the 2 pi, and then plug in the pi. The notation I usually write is cosine of t, and then I evaluate it at pi and 2 pi, because cosine of t is the original. All right, cosine of 2 pi. 2 pi is all the way over here. This is 1, 0. Cosine is the x, so that'll be a 1. Cosine of pi, this would be negative 1, 0. Cosine's the x, so that would be negative 1, and you get 2. And obviously you could check this on the calculator, but you need to practice without, because these kinds of questions may be without a calculator. All right, another weird problem. The original is 3 to the t. So the derivative of 3 to the t, just to remind you, is natural log of 3 times 3 to the t. So let's look at what we have. We have the integral of natural log of 3 times 3 to the t. Well, that's the derivative. So I know that the original is 3 to the t. So there's the original, and then I want to evaluate it at 0 and 1. So 3 to the 1 minus 3 to the 0, and you get 3 minus 1, which is 2. All right, I want you to try this one. You only have one try problem. And then I also want you to finish the second free response question that I talked about in class today.